All right, so they refer to distance and midpoint when you first open this section with maps. Now we think of linears as lines, not curves. When you talk about spherical geometry, you actually start talking about curves, which is what like latitude and longitude are. Those are lines that are a different type of line, not Euclidean, but spherical. And so the same is true, though, when you're measuring distance from city to city. You're really just taking one point to the other point and seeing how far away you are. Now, in the coordinate plane, it actually converts to something you're familiar with. The whole formula for distance comes from Pythagorean theorem, a squared plus b squared equals c squared, which we tend to remember really simply. But what they've done is they have just taken, I want to know how far this point is from that point. Well, if you look at that and you were to draw these lines connecting the x's and the x's and the y's and the y's, you see you have a right triangle. And what you're actually trying to find is the length of the hypotenuse. Well, the length of the hypotenuse fits into a squared plus b squared equals c squared, right? The two sides equals the hypotenuse squared. Well, how do you find those lengths? How do I find the length of this? Well, this is just the distance between the two x's. Subtract your x's. Well, how do I find this length? Well, this is just the distance between the two y's. Subtract those, right? And so the distance squared plus the distance squared equals the distance squared, okay? So that's how we come up with this formula. They subtract their x's and square it, a squared, plus they subtract their y's and square it, b squared, and that equals c squared. Well, since we're finding c and not c squared, in any Pythagorean theorem formula where you were finding the hypotenuse, you had to take the square root at the end. And so that is where the distance formula comes from. The distance is the square root of your x's subtracted and squared plus your y's subtracted and squared. It does not matter. Now, with slope formula, you have to do it in the same order, right? If you do y2 minus y1, you have to do x2 minus x1, right? It actually does not matter for distance formula. Why does it not matter which order I subtract these in any way, shape, or form? Why does it not matter what order I subtract?
Because you're trying to find the distance squared.
Right, but because you square them. So if I do 5 minus 2, I get 3. If I square that, I get 9. If I do 2 minus 5, I get negative 3. If I square negative 3, I get 9, right? And so it actually doesn't matter. As long as you just subtract them and square them, you're going to get the right answer. I will say the biggest problem people get is they forget this is a plus, not a minus. So remember, it is a squared plus b squared. So while you subtract within it to get the distance between the two x's, you always add those two groups that you have squared, all right? So find the distance. It's really easy to find the distance when you have 2 points. You literally just plug them in. All right, so we're going to say the square root then of negative 4 minus 1 quantity squared plus 2 minus 7 quantity squared. Negative 4 minus 1 is negative 5, but I am squaring it like we have mentioned. 2 minus 7 is also negative 5 that I am squaring. So I'm getting the square root of 25 plus 25, which is the square root of 50. They can ask for this answer in two ways. They can say exact. Exact means you need to simplify the radical. Or they can say rounded to the nearest tenth or hundredth or whatever. So depending on how they ask for the answer is how you're going to give it to me, right? If I want the exact answer, then you need to take this guy and you need to do your factor tree and get the exact answer. So the factor tree, 2 and 25 and 5 and 5. Remember, if it pairs up, it comes out of the radical. If it does not pair up, it has to stay in. So 5 square root of 2 would be the exact number. That is the exact number. If they say round to the nearest tenth, right, you would put this in your calculator and you would get something like this. Nearest tenth, though, just a reminder of rounding, that is your 10th place. To round, you look at the guy next to it. 5 and above goes up, 4 and down stays. So this would actually round to 7.1. So I literally just want the middle of the x's and the middle of the y's, right? So to find midpoint, you literally average your x's, and that's your x value. You average your y's, and that's your y values. So you add here. Remember when you're averaging, you add everything up and divide by how many you have. So for the midpoint, I'm going to add my two x's and divide by 2. That is the x value of my midpoint. For my y's, I'm going to add my y's up and divide by 2. That's the y value of my midpoint, okay? It is a point. So distance is a one answer, right? Because you're finding the distance. Midpoint is an x and a y because it is a point, okay? And I say that because some people give me like one number for midpoint, which doesn't make sense. Midpoint is an xy. It is a point, okay? So you're averaging your x's, averaging your y's, and that is your midpoint. Find the midpoint. Well, this is really simple, and your midpoint can be negative. Your distance cannot be negative. You have squared two numbers, added them, and taken the square root. Distance can never be negative. Your midpoint can, because it's literally a point on the coordinate plane. So I'm going to plug this in. I'm going to add my x's. I'm going to say -3 plus 1, and that will be divided by 2. That is my x value. 4 plus 9, and that will be divided by 2. That is my y value. And then I just calculate it. -3 plus 1 is -2 over 2. 4 plus 9 is 13 over 2. If you can simplify it, simplify it. -2 over 2 is -1. 13 over 2 cannot simplify. You are welcome to leave it as an improper fraction. Just make sure you reduce it if you can. This would be your answer. -1, 13 halves.